Hello students, in this video we'll see several examples of using the geometric series formula. Let's recall that if we look at the sum, n goes from k to infinity of r to the n, what this will be is this will be r to the k, where the index starts, over 1 minus r. This is the geometric series formula. And the geometric series formula is valid as long as the value r, an absolute value, is less than 1. So let's see some examples of using this formula. Let's compute the sum. N goes from 1 to infinity of 3 to the n minus 2 to the n over 7 to the n. What we can do is we can break up this sum into two parts. We can write this first by the linearity of the sum as the sum from 1 to infinity of 3 to the n over 7 to the n minus the sum n goes from 1 to infinity of 2 to the n over 7 to the n. And now individually, this first sum over here is the sum n goes from 1 to infinity of 3 over 7 to the n minus the sum n goes from 1 to infinity of 2 over 7 to the power n. And so we can examine these sums. We can see over here that my r will be 3 over 7, and my r over here will be 2 over 7, so we have two separate geometric sums to evaluate, and my k value over here is equal to 1 in both cases. So this first sum over here will evaluate to 3 over 7 over 1 minus 3 over 7, and then we'll have 2 over 7 over 1 minus 2 over 7, which we can simplify. This first thing over here is going to be 3 over 7 over 4 over 7. And this will be 2 over 7 minus 5 over 7. So 2 over 7 over 5 over 7. So this will be 3/4 minus 2 over 5. And so we see that all total, if we add these together, we get 15 minus 8 over 20. So the sum will converge to 7 over 20. Let's consider another more abstract example of this. If we wish to find the sum n goes from 1 to infinity of r to the 2n over 1 plus r squared to the n minus 1, well, we need to identify what the corresponding r's in this problem. Now, whenever we see a constant, like this -1 over here as an exponent, we can pull that term out. So I have a 1 plus r to the -1, that's in the denominator, so that means we can pull out a 1 plus r squared, because that's 1 over 1 plus r squared to the -1, and then we have the sum, n goes from 1 to infinity, of r squared, I'll write that as r squared to the n over 1 plus r squared to the n. And so we see that everything is raised to the power n in this summation, so we have 1 plus r squared, and then the sum from 1 to infinity of r squared over 1 plus r squared, all raised to the power n. So now this is my common, that's my ratio over here, r. So we can use our geometric sum formula, and this becomes 1 plus r squared. And then I'm going to have a r squared over 1 plus r squared over 1 minus r squared over 1 plus r squared. And to simplify a little bit, we can multiply the top and bottom by 1 plus r squared. And so we'll have a 1 plus r squared out in front. And then we'll have an r squared on top. And then we'll have an r squared, 1 plus r squared, and then minus r squared. So this whole thing will just turn into an r squared. So this will be r squared and then 1 plus r squared, and that's the solution to this problem. So whenever solving a geometric series problem, you need to identify what the corresponding value of r is. Then, determining what k is, you can apply the geometric series formula. Thank you very much.